We're back in DC and the AGU fall meeting is well underway, so stay tuned. Hello and welcome to day 2 of AGU TV. I'm your host, Stephen Horn. The AGU 4 meeting brings over 20,000 attendees to engage in all the latest and greatest science from around the world. AGU TV is here to cover it. Today we're stopping by the exhibit hall. We have an exclusive interview with the AGU's incoming president, and we're touring top universities and organizations doing cutting-edge work in science. Absolutely delighted now to be joined by the incoming AGU President, Robin Bell. Robin, welcome.
Oh, lovely to meet you.
Thank you very much indeed for taking the time to talk to us today. We really appreciate that.
Well, it's really great to be here at the fall meeting.
So you're running a session on sexual harassment. Tell us a little bit about that.
Well, sexual harassment and bullying has been a real problem in our field, but it's something we haven't talked about. But over the last 4 years, AGU has really identified this as a problem and actually put in place an ethics policy where AGU, our community, defines bullying and harassment as scientific misconduct, on the equivalent of plagiarism. And it's getting it so we're talking about it. It's the first step towards addressing a problem.
What will you be talking about at the session specifically?
At the session specifically, we're bringing experts in this topic. People who've studied how prevalent it is in our field, how prevalent it is in our field where people particularly go in the field, go to remote places. Antarctica, like I go, the middle of the ocean on research ships, how prevalent it is in our field where you take people out of their normal environment and isolate them, and where we find that harassment and bullying is far more likely to happen.
It's quite staggering to an outsider that this is so prevalent in the 21st century in the scientific community.
It probably has to do with this isolation and the acceptance of this behavior, and the fact that we live in a very hierarchical structure without people shining a flashlight in to see what's going on. And that's what AGUs do. AGU is really at the forefront and has been recognized by the National Academy of Sciences as being the professional society that has put this topic on the table and is now addressing why it is we're losing women from our field.
And so you just launched Ethics and Equity Center in partnership with a number of other scientific organizations. Tell us a little bit about the work of that center.
Some of my vision is we're finally talking about the problems in our field, and our goal is not just to figure out how to punish people. I kind of consider that the whack-a-mole approach. Really isn't going to change things if you just not really going to do a lot for us. Our goal is to both provide the tools to address the current problem and also start to talk about how we do that pivot from, oh my gosh, we have a problem, to this is how we're going to do science. This is how we're going to make science open, ethical, welcoming, environment where everybody can be productive and solve the important problems that are in Earth and space science.
Robin, thank you ever so much indeed for joining us today. We really appreciate that insight. Thank you.
Lovely to chat.
As you should know by now, throughout the show we'll be touring some of the very best scientific universities and institutions from around the globe. Let's begin today with EarthScope.
When EarthScope was started, some of the key goals were really to map out the structure of North America, the continent, and the mantle beneath it, and really look at its properties, temperature, and ultimately its strength. EarthScope has now, at this point, kind of blanketed Alaska and the rest of the lower 48 with seismic and geodetic instruments. So it's been an incredible tool for discovery. We've seen things that we never even knew we were looking for.
from the very beginning, the National Science Foundation recognized the Earthscope's potential to make big advances in the field of earth sciences, primarily because the instrumentation would be very densely spaced and would be widely distributed across the entire North American continent.
Earthscope is like a telescope looking down inside the Earth. And it used three main kinds of tools. There was a seismic network or seismic array called US Array. And this basically rolled across the continent and is currently deployed up in Alaska. And the idea of that was to actually make images of what's inside the Earth.
The US Array helped us to be able to image the whole continent in a way that we hadn't been able to before. That a good example of this would be the thickness of the crust that we live on. We were also able to look even deeper down underneath the continent and see the trail of a dead plate that had been shoved underneath millions of years ago, coming in from the western part of the US and now buried under the central and eastern part of the US.
The San Andreas Fault Observatory at depth is about a 3-kilometer long borehole into the San Andreas Fault over a segment that it creeps, so it doesn't generate large magnitude earthquakes, but it just moves slowly, or what we call aseismically. The goal being to drill through the fault, to instrument it, to collect samples, and to just observe all we could about the fault zone. We've really shown that the San Andreas Fault, its intrinsic properties are very weak here. Previously been debate over whether it was a weak or strong fault, whether it slipped aseismically because of pressure along the fault zone or if it was just the actual material properties. And SAFOD, with sampling of the core and being able to do laboratory measurements on it, really showed that this is really weak material.
PBO, or Plate Boundary Observatory, is a network of over 1,000 really sensitive GPS antennas that are mounted to bedrock throughout the United States.
The Plate Boundary Observatory, which is a geodetic network, so using high-precision GPS instruments to measure the active deformation of the continent. So that would be tectonics, just the plate tectonic deformation. That would be earthquakes. And it turns out there are also other kinds of slip that happen on faults. Earthquakes are fast slip. There are these kinds of slow slip. And we can measure that with the Plate Boundary Observatory. And so this gave us great tools for looking at both the structure and the dynamics of the continent.
One of the cool things to result from the project is this new field called hydrogeodesy. Hydrogeodesy is using GPS signals to infer information about the Earth's hydrologic cycle. So you can do things like measure groundwater, soil moisture, snowpack, or even tidal level with GPS data. The data from the PBO have been used for a variety of different things, from understanding the evolution of the recent California drought to quantifying how much water was dumped in Texas during Hurricane Harvey. The data from the PBO network are going to continue to be useful for many years.
There's two ways that people can easily have access to what science and educational activities have come out of Earthscope. If people go to the Earthscope website, they can look at the Science Nugget map, and the map shows different links to descriptions of different projects that have been funded because of Earthscope. Additionally, there's an app called Flyover Country that people can download to their phones, and when they're traveling on an airplane, they can look at the app and learn about different Earthscope discoveries, and it's available offline and online, so there's no trouble when people are up in the air and they don't have Wi-Fi access.
Earthscope also encouraged people from different disciplines to work together. The fact that we had all of this data and this geographic scope really encouraged people to bring together information from multiple sources in a way that doesn't always happen naturally.
Earthscope has been enormously successful. I see the legacy as really having 4 parts. The first part is the science that was able to be done that we otherwise wouldn't have been able to accomplish without Earthscope. The second part of the legacy is the data. A lot of different seismic, geodetic data were recorded as a result of Earthscope, and that data will be available forever. The third part is the instrumentation. A lot of instrumentation was installed across the United States through Earthscope, and much of that instrumentation has been adopted by other federal, state, and local agencies. And then fourth, the people of Earthscope. A whole generation of scientists were educated as a result of Earthscope, and they are now scientists and making their own contributions to the field of earth sciences.
The 21st century is the century of ocean. However, ocean exploration and development is characterized by high technology, high risk, and high investment.
How to integrate the multi-channel information and how to coordinate multi-institutional infrastructure are the major challenges in ocean and climate science right now.
更需要我们全世界的科学家联合起来，共同协同攻关，来共同来认识海洋，来开发海洋，让海洋为人类造福。
The establishment of Marine National Lab was approved by China's Ministry of Science and Technology in 2013. Our national lab is in the best position to pursue synergy for ocean research through gathering resources at home and abroad. Qingdao National Laboratory for Marine Science and Technology focuses on advancing both fundamental and cutting-edge research by integrating resources and talent, forging partnership, and sharing major facilities worldwide. QAM is designed to cover nearly all marine disciplines. We have been working on issues such as ocean observation, resource utilization, and marine ecological environmental protection. To pursue solutions to those global challenges, we are leveraging the state-of-the-art technologies to support relevant research. QAM activity promotes the construction of the third ocean drilling vessel in the world, with the aim to break through the Earth's crust and enter the mantle. High Performance Computing Center provides technological support of computing science, artificial intelligence, and big data. QAM sets 4 types of research units: functional labs focusing on fundamental research, joint labs focusing on technologies, open studios invite teams worldwide to conduct projects, and overseas research centers for collaborative research.
We integrate resources and professional team all over China to conduct the research. The Laboratory for Marine Mineral Resource focuses on 4 research fields: marine gas hydrate, oil and gas, solid minerals, and key technology for marine mineral detection. Our lab established this technical system for the gas hydrate in the water for the first time in 2017. Results has played an important role in the gas hydrate production test in China.
The Functional Laboratory for Ocean and Climate Dynamics focuses on the structure, dynamics, and variability of oceanic processes in the coastal seas, the open and deep oceans associated with climate change and environmental change. For example, the temperature, salinity, circulation, response, and feedback to climate variation in the China Seas and the Western Pacific. Interdisciplinary and collaborative research is essential in this lab since the scientific issues associated with climate change are so complicated and comprehensive.
We aim to build high-resolution Earth system model to simulate the environmental changes over the past 25,000 years with light of Taihu supercomputer through cross-disciplinary collaboration. The Infrastructure and Innovation Center for Marine Drug Screening and Evaluation in QAM has united over 20 research teams from 5 countries including China, US, UK, France, and Spain. This is the first time in the world to screen active drug molecules in such a large scale. Qingdao is home to 30% of China's marine institutions, as well as 50% of its marine talents.
青岛海洋科学技术国家实验室位于中国青岛蓝谷黄海之滨。青岛蓝谷是一个以海洋为特色的高科技研发和高技术产业的聚集区。为了实现这个目标，我们集聚了中国最顶尖的海洋科技创新平台海洋国家实验室，也集聚了一批科研院所和产业，这样的话打造了一个产学研相辅相成的一个创新生态体系。包括我们国外的科学家到这儿来跟国家实验室合作。
QAM has established a number of open infrastructures for marine research. Scientists worldwide can access such infrastructures as the world's fastest supercomputing center in marine field and the research vessel fleet to support their research. We highly value international collaboration. To facilitate a cooperation among the global marine community, we have held 2 rounds of Global Ocean Summit, gathering over 200 leaders of top marine institutions worldwide. To gather top scientists and engineers worldwide, we launched the Ocean Talent Program to provide the most enabling research environment for scientists. We are establishing overseas research centers with the world's best marine institutes, working with Australia's CSIRO. We launched the International Center for Southern Hemisphere Ocean Research. I'm looking forward to world-leading integrated marine research center to tackle the most pressing global challenges and conducting cutting-edge research for the benefit of humanity.
Climate change is definitely the greatest threat that our forests have ever faced.
Climate is interacting with existing stressors and exacerbating them in a lot of ways. Sometimes you see that out west, for example, big fires or big pest outbreaks, and it's very dramatic, even lethal.
In California, we've seen 130 million trees that have died just since 2010.
In other places, it's a slower change in which you just don't get the reproduction in the forest that you used to, and the competitive relationships between different species in the forest are changing. And so the forests that we know are not going to be the forests that are there even decades from now.
The key to pre-storing our forests for a changing climate is science. Science is our crystal ball for looking into the future and understanding the conditions that our forests are going to need to survive in decades into the future. So that's one of the reasons why American Forest is so excited about working with the Northern Institute of Applied Climate Science. They're sort of like our crystal ball for understanding these scientific changes and helping us and our partners to think about how to use that science to adjust the way that we care for forests into the future.
NIAC staff use a process that involves investing a lot of time, building relationships with individuals, with groups, with all kinds of stakeholders, and asking those stakeholders what they need.
One of the ways that we help organizations pursue climate adaptation planning is through a process that we created with lots of partners called the Adaptation Workbook. And a critical part of any adaptation is to understand what it is that they value, what it is that they want, what it is that they need to do, and then ultimately use that to ground the entire conversation, to ground all of the planning, so that they're always coming back to what is it that they are most valuing in this forest.
I'm Rachel McDonald. I'm the forester for Keweenaw Indian Community. I help to manage Lance Indian Reservation, which is about 66,000 acres altogether, but the tribe owns and actively manages about 18,000. Climate change poses a threat for reducing the winter weather window. We've seen a reduction of the time that we have frozen soils, which really creates a problem when you want to get heavy equipment into the woods to harvest timber.
The Keweenaw Indian community is really interested in a wide variety of different values associated with their land. So we go through the adaptation workbook, which breaks down this overwhelming issue of climate change and helps deal with it in smaller pieces of information, smaller chunks, so that way we can think about how is the particular place vulnerable to climate change, how might the tree species or ecosystems change, how does that affect the management that they're doing, and then what ultimately can they do to help enable their ecosystems to be better adapted to future conditions.
Climate change, it's such a huge issue that previously I didn't know where to start. Going to their workshop really made me have to stop and learn how to integrate climate change into my decision making. We've had to be creative, working with NIAX to track our equipment operable days in the winter, and being careful and cognizant about protecting more sensitive areas in the summer so that we could have timber harvests in non-winter periods.
Our work at NIAX is really intended to help bring the best science that's out there into the hands of managers rather than just having it be stuck in journals and in places where people can't access it. We want to be able to bring it out to light and get it into the hands so that people can make better informed decisions.
NIAX is also a great partner in working with policymakers, something that's very important to American forests, to translate complicated scientific principles into easily understandable guidance and direction for what to do is just as valuable for policymakers as it is for forestry practitioners in the field.
American Forest sees itself as a movement builder and a movement leader. We can't do what needs to happen for our forests alone. We need to be working across the sector, and we do that through collaboration and through coalitions.
Like the Forest Climate Working Group and our work with the United States Climate Alliance. Through these coalitions and partnerships, we're using tools developed by NIAX and other partners to help create a new movement for climate-informed forestry across America.
Certainly American Forest is one of those organizations that are at the forefront of thinking, how do we pursue forest restoration in a climate-informed way? How do we design pro-forest policies that themselves are climate-informed and that can help ensure that our forests continue to sequester carbon and help slow down the accumulation of greenhouse gases in our atmosphere? And we are ecstatic to work with them. The people that we serve, that I get to interact with on a day-to-day basis, they are absolutely dedicated to being good stewards of the ecosystems that they manage. And when we help them to be more effective in their jobs, how can you not love that?
We're here in the AGU exhibit hall and we're at AGU Central. Come along and check it out.
So this is AGU Central. We're literally in the center of the exhibit hall, and this is where members can come to purchase AGU merchandise. They can renew their membership. We have, as part of our centennial this year, we have a narratives StoryCorps booth where members can come over and talk about their science. Anyone who shares their story as part of the narrative program, they get to have their Polaroid taken and put up on this wall here. So this is where we're having presentations throughout the week. So you see we have the schedules, there's things going on for our data program. We're asking members to show us where they traveled from, just to give an idea of the global network. So this is our selfie wall over here. Do you want to get a selfie? Yes. All right, come here. And attendees can donate to the Austin Travel Grant Challenge. So this is going to be a staffed area throughout the week at various times. Members could come and put their money in there. You can take donations online, and that donation will be doubled up to $1 million and matched by Jamie Austin.
We're going to talk about explaining extreme events now, and I'm absolutely delighted to be joined by Jeff Rosenberg and Julie Vano. Jeff, tell us a little bit about the Explaining Extreme Events paper.
So Explaining Extreme Events is a special edition of the Bulletin of the American Meteorological Society. We've been doing this for 7 years, and in this 7th volume we've seen so much growth in the number of papers that are coming out that are doing this sort of attribution science, that we're starting to see a shift in the focus of what we do to serve the society better, to serve our researchers better. So these 17 papers that we've collected this year are covering droughts in Africa, they're covering floods in South America, they're covering all sorts of extreme weather events, some of them marine events like a huge warming in the oceans off of Tasmania. So the thing is that this kind of extreme weather is a major effect on society, right? This is how we live. We live in daily weather. But attribution science can connect what's going on daily, what's going on regional and short seasonal scales, to climate change. And not just the climate change, but to the human effect on climate change. So that's the attribution part of all of these papers. And as a sum collection of papers, we're seeing a tremendous message to society that if we can make these connections and we can look at what we're living through every day, we can see that there's a new climate emerging and that it's due to human impact. And we can assess not only that there's a connection, but that the risk is quantifiable. So it's a little bit like going to the doctor and the doctor sees that you've got a pack of cigarettes in your pocket. And he says, well, you know, I have bad news for you. He's not going to say you're going to get lung cancer. He's going to say your odds of getting lung cancer have really skyrocketed.
Well, let's talk just a little second about those odds. So are those odds getting better or worse?
Well, better if you like to see crazy, unexpected things. Worse if you're not prepared. And I think being prepared and understanding the changing risks is what these papers are all about. But we need society and we need decision makers, we need Wall Street to take a look at this. And you know, they don't make decisions where they don't know the situation. If they're going to give you money to build something, they want to know the facts. And the facts are that risks have really changed dramatically with climate change. You can't plan for a flood based on the 30-year data that you had the past 30 years. That's a different climate. So Julie, I think, really covers that really well in the report, in that we're starting to gather up opinions and facts about how people use this information, because society is on a wholly different basis now because of this.
So Julie, how does that relate to water management?
Well, so this is incredibly important to water managers. They are facing extreme events that are well beyond their experience and well beyond what we see in the historical record. And they're wondering, what does this mean? Should I believe this forecast or should I not? And what do I do? And I think this science has it provides a great opportunity and a tool that we can better understand how we look forward. That said, I think the science community really needs to connect with the decision makers to understand what it is that keeps them up at night. And by understanding that, we can better ask questions that address their real world concerns and make our science more actionable.
And you see these issues that we're talking about today playing out in the real world. That's what you're saying?
Yeah, yep. No, there's definitely, the chapter that I was a part of putting together is done by the American Meteorological Society Water Resources Committee, and they're a collection of folks from public utilities, from consulting firms, from federal agencies and academic institutions.
My last question, if I could. What do you think, a lot of people here this week, 24,000 I think, what would some of the takeaways be that you would suggest for this community?
I think a couple of takeaways. First of all, for this community, a research community, it's important to know that their science has an impact on the way we live and what we can afford to do as a society. It's such basic information now to know how climate change is changing things. They've got to reach out. They've got to reach out, as Julie said, to inform how they ask the questions that they're asking, and then also to help the world use that information in their decision-making models.
Well, thank you both very much indeed for joining us today. We really appreciate it. Fascinating stuff. Thank you.
Thank you.
Heliophysics is the study of the sun, but not just the sun's influence on everything in the solar system, interacting with planets, with moons, asteroids, comets, even the spacecraft and people we have in the solar system. And the work we do here at Goddard is unique because we have the largest collection of heliophysicists in the world that cover the gambit of theory and modeling to answer fundamental questions, which then drive the development of instruments and missions, and also address something that's crucial to our understanding and our society, space weather.
Space weather effects can come in many ways, and it can be caused by different things. For example, solar flares, which are abrupt eruptions of radiation, or coronal mass ejections, CMEs, which are big explosions of particles that travel several million miles per hour. These events also can actually accelerate high energetic particles to very high velocities. It could cause problems in the instrumentation and satellites, problems in communications, GPS signal loss, and even power grid disruptions. We depend too much on this kind of technology, and that's why we have to study, and it's critical for us to study the near space environment, the space weather, so we can understand how we can mitigate these events.
Theory and modeling is very important to every thing that we do in the Heliophysics Science Division to quantify what measurements are needed to distinguish between competing explanations of an outstanding question. It is important to know what to measure, where to measure, and to what accuracy to measure. This is the sort of information that theory and modeling efforts help provide. Then, armed with that information, instrument developers and mission PIs can design their instruments and operational approaches to ensure they will be successful.
I work with the Community Coordinating Modeling Center. It's a multi-partnership agency established in 2000 that the core goals were to actually support the research in space weather and also to actually facilitate the development of the next generation of space weather models and tools. As a part of that, we do a service of monitoring and doing forecasting for NASA missions. And we do this in the way of having an in-house real-time prototyping of the new tools so we can prepare the models and the tools to operations.
In order to understand solar energetic particles, we have to detect them in space. So to detect them, we need to use modern instrumentation, and our instruments based on modern scintillators and modern readout devices. The way that scintillators work is that they actually produce a tiny amount of light as the particle traverses through the scintillator. Now the key is to be able to measure that light, that very small amount of light. What our lab has actually been doing is taking modern devices, these are silicon photomultipliers, and making large area arrays of them that can replace the bulky photomultiplier tubes of the past. So we can actually fly this type of miniaturized technology on small sats such as CubeSats.
As a scientist, the dream is to have something really beautiful, really captivating that you can talk to people about, but you can actually get very detailed pieces of scientific information. The aurora is arguably the most visibly captivating manifestation of this relationship between the sun and the earth. What we do in our lab is we try and actually fly rockets that go through the aurora and above the aurora and then come down in a very short time frame so that you can capture the particles that are creating it over here, and you can also have the opportunity to look at the light from below. And with those instruments, we have two goals. We want to know how many particles did we get, what energies were they at, and other properties, but these are the most important usually.
Data drives theory and modeling, which then drives new instrumentation and missions, which ultimately brings us new data and starts that cycle of discovery all over again.
The work that we do here in heliophysics is so important and has many broad implications, both for planetary science in our own solar system and beyond to planets around other stars, so-called exoplanets. By understanding the extreme space weather that these close-in exoplanets are constantly encountering, we can understand whether these planets are in fact habitable, and we can derive a better understanding of space weather and its impacts for our own planet and way of life.
One exciting aspect of what we do in the Heliophysics Science Division is in fact a fundamental goal of NASA to communicate the science and technology which we and our colleagues develop through science communication, science outreach, and science education. And we're embedded with the largest collection of space and earth scientists. This allows for a truly cross-disciplinary group that's not only addressing NASA's goals in heliophysics, but NASA's goal across all the science disciplines and supporting all the missions that NASA and its partners bring to the world.
Back 50 years ago, our founding father, Dr. Vern Sumi, actually put up the first demonstrational satellite. And his vision was, let's put observations that we can now do on the surface of the Earth. Why not put them up in the sky and look down? Because it's the clouds that move, and we want to be able to see those clouds moving. And he started us off. And his legacy lives on in all of us that are still doing research here. Since then, the program has evolved from these really big satellites, they're bus size, and then they got down to, maybe car size, which they are today. But the idea is that these are very big and bulky and heavy, and there's a lot of power needed to fuel them. So really, it's an economic decision that if we can use new technology that's available today to make, with lighter materials, better optics, better power sourcing, we can get these satellites down to the size of a breadbasket.
They are smaller, they're easier to launch, they're less expensive, so if we lose a few, we can just launch replacements. We still want the big satellites up there, the big buses, that are going to be up there for many, many years, but we also want to launch these smaller satellites so that we can have many, many of these satellites passing over the storms very quickly.
NASA has already decided that they are going to go to using these smaller platforms for as many of the different variables that we want to measure about the climate system as possible. And PREFIRE fits right in with that by demonstrating the technology, being one of the pioneering missions that actually will make measurements using this platform.
Probably the more important part of the Tropics mission is to demonstrate that a fleet of small satellites can do the job that in the past would have been done by a huge satellite the size of a minibus that costs $1 billion. So it's really important to have missions like Tropics that demonstrate that small satellites on a lower budget, on a more rapid development schedule, can still acquire the same data with the same quality that you could do in the past with huge, more expensive satellites.
So the Earth's energy cycle is pretty much driven by just two factors. It's the amount of sunlight that comes in and the amount of energy that the Earth emits back to space. And there should be a balance roughly between those two quantities. But the solar part tends to come in more in the tropics, which is why our tropics are warmer. And most of the emission tends to occur in the polar regions. And so what PREFIRE is going to do is it's going to basically map out that second portion of that energy balance. We're going to really try to understand how much energy is emitted from the polar regions, how much energy the atmosphere traps in the polar regions and keeps back into the Earth. And in doing that, we should be able to understand how the flow of energy between the tropics and the poles actually works and how that impacts the weather systems and the climate on Earth.
The Arctic is warming much faster than the global average. And the Greenland ice sheet, if it were to completely melt, would lead to 7.2 meters of sea level rise. Current observations of the Greenland ice sheet indicate that the edges of the ice sheet are undergoing rapid melting, but that the center of the ice sheet actually has a small net gain of mass. And this gain of mass is through the production of snowfall. So if we can better understand clouds and snowfall over the Greenland ice sheet, we can help inform and make more accurate predictions of future sea level rise.
So my research looks at air pollution, and I use computer models and satellite data, as well as measurements from ground-based networks around the world. Air pollution is the #1 environmental risk to human health. It's associated with shorter lifespans, with asthma attacks, with respiratory disease, and things like having even itchy eyes or sneezing. And some of the chemicals in the air we can see, like smoke from a forest fire, but many of the most dangerous chemicals are invisible to the human eye. So it's pretty cool that satellites can see these chemicals from outer space, even if we can't see them right at ground level with our own two eyes.
Those forecasts then can be used by regional planning offices, state schools, particularly kids with asthma are very susceptible to ozone and aerosol pollution. We work both with the NASA scientists and the NASA satellite data, and we work with the NOAA more operational side of air quality predictions and how we might, again, use satellite data to help improve our understanding of what the air quality is today so we can help better forecast it tomorrow.
Almost every time a new satellite is launched, we're like right there. We're like, either in the design process or in the processing process or in the storage. And it's just a very rewarding work to be working with this new data. You know, whenever a new idea comes along on how we can observe storms, we're right there. That is our legacy, and we're continuing that forward with these new missions.
This is the Department of Earth and Environmental Sciences at Rutgers University in Newark. It's an urban campus. We attract a lot of students from urban areas, and we really make it a mission of this department to help attract these students and help them to thrive in the geosciences. We have 9 faculty members, 8 TAs, 70 undergraduate majors. We probably have about 25 to 30 graduate students.
I attended Rutgers University here in Newark, and now I'm working in the environmental industry as an engineer. The courses I took in the major I was here, it really prepared me for all the field work. We did go out and observe rock outcrops. The writing absolutely prepared me for it. All the reports I write, and just being able to understand the natural world.
I love it. The geology department is so supportive. Dr. Mihaela, she really helps me. Like, she's teaching me SEM right now. They really focus mainly on undergrads and helping them understand the instruments and actually understand geology itself.
The department kind of focuses on 3 specialized areas. We look at pollution of air, water, and soil. Okay, and so one of the parts of that is geophysics, and these are environmental geophysics that look at just the shallow subsurface using remote methods to be able to see what's underground without having to dig a hole. The next part is to look at chemical pollution. So they're geochemists. They work with air, water, and soil pollution. And then finally, we have some geobiologists who work with microorganisms and how they deal with the polluted environment.
I'm interested in the preservation of biosignatures and carbonate rock. So I'm currently looking at stromatolites from both Morocco and locally in New Jersey. The main goal of the research is to see if we can determine if there's a texture of a rock or a chemical signature that may indicate life or a biosignature preservation.
Mihaela Glomaclea is an assistant professor in this department, and she works on very interesting stuff where they look at extremophiles, things that can live in extreme environments, and right now she is modeling how life began on Mars.
Our field areas that we are studying are usually used as terrestrial analogs to other planetary bodies. So the most frequently we are looking at systems on Earth that resemble in some ways systems on Mars. And we want to provide space missions with technological and scientific framework within which they can do research on other planets and specifically detect life on other planets.
Dr. Adam Kuska is in oceanography, geobiology. So he looks at bigger scale pictures, global scale of microorganisms and how they are impacting with global climate change.
I work on marine phytoplankton. Marine phytoplankton are very important for fixing carbon dioxide. They fix about half of the carbon dioxide on an annual basis, with land plants doing the other half. It seems that marine phytoplankton are iron limited in vast regions of the ocean. Our lab strives to understand how different marine phytoplankton or marine algae compete with one another for iron. One recent development in our lab, which stems from a collaboration with our colleagues at the Craig Benner Institute in California, we unraveled a novel mechanism of iron uptake in algae that seems to resemble the uptake pathway in human blood cells.
We had a really exciting addition to the department just recently. And what we did was we obtained the Meadowlands Environmental Research Institute. And this is a field research lab that sits out in the middle of the Hackensack Meadowlands. Overlooks New York City. You see the New York City skyline in the distance, and yet the area looks pristine around it. Now it isn't. It's highly polluted underneath, but on the surface, it looks like a beautiful place to go.
Here we create the professional and the scientist who is going to be working in the front line of the pollution and mitigating this pollution and understanding the challenges and figuring a way around, global warming and sea level rise in these low-lying areas. A lot of the contamination is below ground, 30, 40 feet sometimes. In order for us to get down and understand what's going on and how much of the contaminant is down there, we have this drilling machine. So we can make holes up to 100 feet down. And we can take samples or monitor, what's going on with the water and the soil interface down there. That's why this is so important to have access to, deep into the soil.
At Rutgers Newark, this area, there's a lot of opportunities for using these geophysical techniques to address critical environmental problems. For example, in these wetland systems I've been working on, I've worked in very pristine systems in Maine, which are very different from what you see here, where we've focused more on understanding the hydrology of these systems and also the release of methane gases to the atmosphere. And we've made pretty profound discoveries using these geophysical techniques.
The biggest challenges that the world is going to face over the next couple of decades are going to be in the environment, whether it's climate change or pollution or global changes, and we want to be at cutting edge in that. Not only do we want the research to be able to predict what's going to happen and try to remediate things before they become really disasters, but we also want to make a very strong, educated workforce that can really address these issues.
So our special correspondent Heidi is out on the conference floor asking attendees the question of the day. Heidi, what's new?
Thanks, Stephen. Today we're out asking attendees what is the one thing they want decision makers to understand about Earth and space science.
The one thing I want decision makers to know about Earth and space science is that the decisions that we make right now to decarbonize our global economy will shape the trajectory of this planet into the planet's future forever. And the things that we do right now matter so much, not only to the community of scientists here, but also to every single living being on this planet, human and natural systems alike.
I need them to work on climate change.
The one thing I would wish that decision makers knew about Earth and space sciences is that climate change is real and it's happening now and we have to act on it. There are 27,000 people at this meeting and almost all of them will agree with that.
The one thing that I want decision makers to understand about Earth and space science is that scientists are people too. We are brown, we are immigrants, we are queer, we are poor, we are tired,
I think the most important thing I want them to understand is that Earth and space scientists have their best interest in mind and everyone's best interest in mind, that they can trust us to help inform them for good decisions.
Lesia is in charge of space instrumentation for various missions in solar exploration and astronomy, and also for ground-based instruments for large telescopes. Lesia has already a long history. We had the first instruments flying on the sounding rockets in the 1970s. We had instruments on Cassini mission, on Rosetta mission, Venus Express, Mars Express, Stereo, many others. But recently we just delivered and launched instruments on Bepi Colombo, and we are now building instruments for the next ESA mission, Solar Orbiter, Plateau mission, Ariel mission, Mars Science Laboratory 2020. We are building with IRAP Space Laboratory in Toulouse an instrument called SuperCam, which will observe the Martian surface and various aspects in the near future.
Exoplanets are studied in many different ways at LESIA and using many different techniques. For example, people have pioneered direct observation of planets. There's a technique called coronagraphy that was developed at Paris Observatory 80 years ago. This technique has been revived since about 20 years ago to observe planets next to stars. But also another technique is to observe, so to speak, the shadow of the planet as it passes in front of the star. This technique was pioneered at LESIA with a satellite which was called CORO, which flew in 2006 and which discovered several dozens planets. And then the next generation of these transit detection satellites is called Plato, and LESIA plays a very important role with Plato, which will fly in 2026. It will observe the full sky and it will provide probably 10,000 planets or more.
We are deeply involved in the Solar Orbiter project. Solar Orbiter will be the next European space mission dedicated to the study of the Sun and its connection with the interplanetary medium.
We are responsible for one of the 10 instruments on Solar Orbiter. This instrument is the radio and plasma wave instrument, which is actually measuring and listening the radio emissions produced by the Sun. And in LESIA we have built the electronic box of the instrument, which has been delivered to Airbus.
Here at LESIA, we are the main group in France, which is studying solar activity from the eruption on the Sun to its impact on the Earth.
In LESIA, we have two groups working on space weather. The solar physics group, which is studying the origin of the perturbation by analyzing images of the Sun, and the plasma physics group, which is studying traditionally the solar wind, the density, temperature, composition, level of energetic particles, and the impact of the solar wind on the Earth.
On the observation side, we are observing the Sun in almost every wavelength, and we have a set of instruments which are unique in the world in radio, white light, and high energy particles. At the same time, we are developing numerical simulation which are able to really understand the way solar eruptions are developing and are happening.
LESIA is, of course, part of a network of laboratories. We work with brother laboratories in France, so we calibrate our own instruments, but also instruments from other places on request from the Space Agency and the request from any laboratories, even if we are not involved from the beginning of an experiment. We have in LESIA possibilities for thermal vacuum tests for space experiments, and also the experience and the quality instruments that we have from a long history of development.
We have 8 clean rooms on the site, and this one was built with especially for planetary protection for the Mars mission. And we maximize the safety of the instrument and also the personnel working outside of the clean room in a dedicated control room. And so we avoid any contamination of the instrument, like particles or excessive humidity, and to avoid any degradation of the performances of the instrument.
The quality of the people that work here is very important for the success of our instruments, of our missions. Because we have very tight schedules, the schedule changes quite often, and so people have to change their task. We have people that are very much involved in their work. They are really concerned with the success of the missions we work on, and so they always do the maximum to go to the success.
In the next 10 years, we already know what instruments will fly and what the observations will be. There are fundamental questions there we are addressing through instrumentation in LESIA, and we hope to have some answers in the next 10 years.
Dataone is a federation of data repositories, meaning that we provide a single access point to discover data from lots and lots of different repositories worldwide. We are doing that in order to solve some very significant environmental challenges that we're facing on the planet and in our ecosystems, and then we as a people. And these include things like wildfires, infectious disease, spread, a whole array of major challenges. These challenges require lots of different types of data in order to understand them and then also to mitigate them. And Dataone provides access to those data from a whole variety of different disciplines and domains.
So Dataone provides a community repository that contains hundreds of thousands of data sets from the earth and environmental sciences. Everything from ecology to oceanography to atmospheric sciences is included in the repository and is accessible for reproducible science. Dataone consists of a diverse community of collaborators from libraries to government agencies to universities, all of whom are focused on either directly or indirectly supporting open data. Partnerships through Dataone like Make Data Count and others really promote open science principles and open data practices.
So Dataone enables researchers to discover and access data across a broad array of data repositories. And as such, it enables researchers to be much more efficient when working with data. Additionally, through the search interface, Dataone provides researchers with access to a user portal, and that portal enables them to see all of the data that they have within Dataone that they have published. And it also enables them to see metrics associated with those data, so they can see the number of times it's been viewed or downloaded and cited. And so that means that a researcher can really track the impact that their data is having on the broader community.
My research really focuses on synthesis science, where I'm reusing data that other people have produced. And in the old days, this could take months or longer to find these data and get them into a format that I could then use. And now with Dataone, with the linking across all the different repositories of data, I can do this much, much faster, which dramatically increases the speed at which I can do the research I want to do, and I can focus instead on asking the questions and doing the analyses I'm interested in rather than digging around for data. So Dataone has really had a profound impact on the pace and the scope of questions that I can ask with my own research.
In addition to being a search portal, Dataone provides a lot of education resources and information on best practices. And so researchers can gain training and information on how best to manage their data. We believe that data management is a fundamental part of the research process, and that the principles of good data management should be taught when students are first collecting data. Our education modules and materials have been used within the community. Libraries, data repositories, domain researchers, federal agencies have all taught from the education materials and have used them to develop their own suite of materials. And in that way, Dataone has really informed the way in which the community practice data management training.
Here at INSEAS and our training initiatives, we point to Dataone for a number of services. We teach researchers in our trainings how to use Dataone search features to try and find suitable data sets for synthesis. We also encourage researchers to archive their data sets to Dataone member nodes through both programmatic R tools, like the R Dataone package, and also through member node web submission forms.
A rich diversity of repository solutions are used for sharing research data. These solutions work well within a community, but the diversity creates challenges when trying to work across communities. Dataone resolves this problem by harmonising the protocols and approaches to sharing data across repositories. And this approach is exemplified by the search.dataone.org web interface, which enables precise, consistent search across all the participating data repositories.
The Arctic Data Center and the KNB partner with Dataone to take advantage of the exposure provided by Dataone and to take advantage of the replication capabilities. So by replicating our data sets amongst a large number of repositories, we ensure that our data are long-lived, and we also ensure that more people have access to those data.
I think the future for Dataone is enormous. The significant challenges that we're facing on this planet really require access to a whole diversity of data from many, many different sources globally. And Dataone is providing access to that data And we're helping to improve the quality of that data so that it really can be used for both research and decision making in the long term.
Harvey took everything that I had, everything I had built up to at that point, all my material. I know it's material stuff, but still, you work hard and you start to slowly build, a life, and everything was lost.
The rain is not as hard, but it's like a steady rain, and that's when I was like, okay, it's still raining, and I see the water start creeping up, and that's when I was like, okay, we may have a problem.
Here at the Pacific Disaster Center, we use science and technology to help reduce disaster risk. What it basically means is that we work on technologies to extend early warning for disasters, as well as we take a look at, through our risk and vulnerability assessment program, we take a look at factors that make the societies more resilient, and that can help with better planning as well as guiding strategic investment in risk reduction and mitigation.
Our disaster-aware system is a collection of data, software, information products. It's used by tens of thousands of disaster managers, elected officials, business executives to monitor hazards, respond to hazards, basically take action to save lives and property. Pacific Disaster Center had been working with ASEAN, and specifically its Committee on Disaster Management, in the early 2000s. Shortly after our engagement with the 2004 Indian Ocean tsunami took place, killing more than 200,000 people. It was that tsunami event, in fact, that provided the impetus for creating the AHA Center, the ASEAN Humanitarian Assistance Center in Jakarta. We worked very closely with ASEAN, its Committee on Disaster Management, to develop a staffing plan and an architecture for the AHA Center. We fielded the Disaster Management Response System, DMRS, one of PDC's earlier versions of Disaster Aware. And we've worked closely with ACDM and AHA Center ever since to upgrade the system, to deliver training, to exercise it annually in their ARDEX exercise. They're a very important partner for us, and they allow us to assist hundreds of millions of people in the most disaster-prone region in the world.
The NDPBA is more than just an assessment. It really is a sustainable system of assessing, understanding, and applying critical risk information for decision-making. It's the foundation for which communities can really base investment or focused investment to reduce risk, increase their coping capacity, and really build resiliency. PDC is very excited about this process because we're on track to have 20% of the world complete by 2021. We have a data set and the application of data like nobody else in the world, which is really exciting for us because it means we can start to ask the questions we didn't even know needed to be asked. So the NDPBA really has 4 key components. First, it starts with stakeholder engagement when we start our risk and vulnerability assessment. We then contextualize the results of the risk and vulnerability assessment with a disaster management analysis. Coming together, we then evaluate that data as a team to understand where we can have the most effect in reducing vulnerability and increasing coping capacity by developing a 5-year plan and for promoting investment in the right area. Now, the really exciting piece about this is that our stakeholders get every single piece of data. And that's something that's really important to me, to make sure that this data and information can be used by stakeholders. This really is PDC partnering with these agencies, organizations, and nations to build resilient communities.
Pacific Disaster Center works with our partners around the world to customize and deploy national and regional versions of Disaster Aware. In fact, we've done that with countries in Southeast Asia and with the ASEAN Humanitarian Assistance Center. One version, called Inaware, is used in Indonesia by its national and provincial disaster managers. We've helped BNPB use Inaware recently for volcanic eruptions in Bali, for a series of earthquakes in the neighboring island of Lombok, and for the earthquake and tsunami that killed more than 2,000 people in Sulawesi.
Here at PDC, we're constantly looking at improving and enhancing the technologies that would help better understand the hazards and their impacts, as well as communicating that information to the audiences. For instance, our mobile disaster alert app came at the forefront of the mobile technology, as well as Smart Alert is a technology that we have developed to help narrow down basically the number of notifications that might be received by an agency so that they're not overwhelmed essentially with too much information. Really our goal for the future is to extend the timeline and take disaster management out of the reactive into the proactive world.
University of Maryland, Baltimore County, or UMBC, is located a few kilometers west of Baltimore and also a few kilometers west of the Chesapeake Bay. We excel in the STEM disciplines, and we also have a deep concern of social equity, social science, and the arts. In the Department of Geography and Environmental Systems, we study social science, natural science, and geospatial technologies, and so our research areas include Earth system science, human geography, urban geography and ecology, environmental impact, ecosystem analyses, and geospatial techniques, as well as an overall response of humans to global change. We're formally affiliated with NASA, with the U.S. Geological Survey, and with the U.S. Forest Service. The primary mission of the Department of Geography and Environmental Systems is a coupling between humans and their environment. We're interested in both how the environment affects humans in terms of quality of life and livability. We're also interested in how humans affect the environment in terms of degradation of habitats, of pollutant loads, and other impacts on ecological systems. The transdisciplinary research that we do in the Geography and Environmental Systems Department addresses wicked, intractable problems that span dimensions from social to natural. And therefore, our impact attempts to understand and pose solutions to those problems. Baltimore has a history of inequity, particularly in terms of housing distribution that's racially biased that leads to poor quality of life.
In order to understand environmental injustice in Baltimore, we really need to look at Baltimore's history of residential segregation. The government deliberately segregated neighborhoods on the basis of race and made it extremely difficult for Black and other minority neighborhoods to access loans. What this meant is that Black neighborhoods were unable to maintain their property values. They didn't have money for revenue, that type of thing. And so this led to both physically deteriorating neighborhoods and also a deteriorating quality of life, with impacts that are still very much felt today.
The Miracle Garden is the oldest community garden in Baltimore and is an example of how urban agriculture can be used to help connect people with their local environment.
This is the Duncan Street Miracle Garden, and it's run as a community land trust. Community control of land is a promising strategy for doing democratic sustainability in cities. Greening is an approach that a lot of cities are taking to urban sustainability, but not everyone has equal access to or benefits equally from urban green space. One thing that I'm studying is who has access to, who benefits from, and who's involved in sustainability planning processes.
Waste material in the urban environment is challenging, and it has a profound effect on both people and the environment.
I study the production and disposal of municipal solid waste in urban systems, and I'm interested in how waste is produced, how it's dealt with, not just today, but in the past, so how that's changed over the course of time and the consequences that has for urban systems.
Urban landscapes have a profound effect on urban bird distributions and their behaviors.
I study the movement of birds in our urban areas, where they go, when do they go, and how this helps them survive the harsh winters and reproduce successfully in the summers. Now, if we know this, we'll be able to be better city planners and better conservationists and increase our own quality of life.
Organisms such as spiders are remarkably sensitive indicators of air and water pollution in urban environments.
I study spiders, and the great thing about spiders is that they're everywhere. So that means that they're breathing the air that we breathe, they are drinking the water that we drink. And so by collecting their food, we're able to measure contaminants that may come from streams. And by collecting their webs, we can collect dust that has air pollution. So really by studying everything about spiders, we can learn more about ourselves.
Extreme storms, such as hurricanes, are among the costliest and deadliest natural disasters.
In the past 2 years alone, we've had 5 vicious hurricanes, 3 of which were Category 4, 1 was almost a Cat 5, and 1 created a horrific flash flood in the Carolinas just this past year. Why these storms become so intense is of paramount importance.
Flooding in cities, due to both urbanization and climate change, pose an increasingly deadly threat.
The Baltimore region has experienced several large flooding events, especially Ellicott City, which has experienced 2 1,000-year flooding events in the last few years. I'm interested in the interaction between urban infrastructure, stormwater mitigation efforts, stream channel restoration projects, and how they affect urban flooding. I use hydraulic models in order to simulate potential restoration projects and their potential outcomes.
Conservation policies have important social and ecological effects in tropical forests around the planet.
I study forests from above. I use satellite and aerial imagery to examine how forests are changing across the subtropics and tropics. I'm really interested in how conservation and agricultural policies are causing landscapes to become fragmented, and in many cases across the tropics, how landscapes are regrowing and being restored through these policies, how they're being reconnected. It's something I'm very interested in, and I think it's very important because it controls carbon dioxide in the atmosphere, human livelihoods across the tropics, and the production of food.
By addressing environmental and social problems in a transdisciplinary way, where social scientists and environmental scientists work together from problem formation to solution, gives us our best chance to address wicked problems such as environmental injustice, urbanization, and climate change.
Absolutely delighted now to be joined by Susan Anenberg, who is, as you know, editor of GeoHealth. Susan, welcome.
Thank you. Happy to be here.
Thank you very much indeed for joining us. It's such a busy conference this year.
It's been a few years since I've attended the fall meeting, actually. It's always a surprise to remind myself how large it is.
So, GeoHealth, just tell me, what exactly is GeoHealth?
GeoHealth is sort of the intersection of geosciences and public health. So it's really, fundamentally, it's how the world around us affects our health.
And what are some of the biggest issues driving that at the moment?
Oh man, there are so many. Some of the biggest issues are global air pollution. That's considered the #1 environmental health risk factor on a global scale. Of course, water quality is always an important factor, specifically in developing countries where adequate clean water and sanitation are not as widespread as we'd like them to be. And then, of course, considering the future, climate change is a biggie. Climate change will affect everything, including our air quality and our water quality and our soils, of course, public health. And then, we're also seeing new emerging issues like chemicals in our consumer products and in our food that we eat, in our soils that we're exposed to. So there's just so many ways that the world around us impacts our public health.
And do you think this is getting more so? Are we seeing more and more implications of that? Or is this just that we're finding out more and therefore it feels like there's more?
Well, the world is changing in very dramatically in different ways. So I would say that some of them are perhaps improving over time. We're seeing that with water and sanitation. Some of them are getting worse over time. Air pollution is improving in some countries like the United States, where we have effective regulations that bring our air quality levels to a safer level. But in countries that are very rapidly developing, we're seeing it worsening. Then of course we have climate change, where we continue to be on a trajectory of very extreme climate changes that we can be anticipating. So it's sort of a mixed bag, but I think certainly some of the environmental health risk factors are growing right now and in the future, and I think there's also growing recognition that those are affecting our public health.
In that growing recognition, how much of a discipline is this becoming, and how keen are students to get involved in it?
I think students are really fascinated by it. It's not always called GeoHealth when people are practicing GeoHealth. Sometimes it's called global environmental health or just environmental health. There's a variety of different terms that people use for similar work. What I notice as the director of the Master in Public Health in the concentration of global environmental health at George Washington University's, our students come really motivated by a passion to improve life for people. They want to make the world a better place. They want to improve public health around the world. And I think we have a lot of students who experience certain they see somebody have a certain disease and be affected by it. Maybe they worked in a hospital and they saw the same patients come in over and over again with the similar health outcomes. And I think they're recognizing that it's really, we're treating the symptoms. We need to be treating the underlying causes of disease. I think students are now recognizing that the world around us, what we're doing to the planet, is also affecting our health. And one of the best ways to make a difference on a very large spatial scale is to work on those environmental conditions that are influencing our health.
Susan, thank you very much indeed for joining us today. We really appreciate it.
Thank you so much.
That's it for today, but we'll be back each and every day of the meeting with yet more exclusive material. In the meantime, you can watch the show all over the Convention Centre, in your hotel room and online, as well as on the AGU 4Meeting app. And don't forget to keep up with all the very latest developments and get in touch via the web. So until tomorrow, when we'll be checking in on the AGU special panel on sexual harassment in science, it's goodbye.